The next formula is about the rotation theorem. This is also one of the most important formulas, and let's do this. If we have three, okay, let's not make it. If we have three complex numbers, three coordinates, or you can say P, Q, and R. Q represents Z2, P represents Z1, and R represents Z3 complex number. Then, and angle PQR, let's say it is theta. Then you can always rotate this PQ line over this QR line. This PQ line to this line by using this formula. Z3 minus Z2, first of all this line upon Z2 minus Z1, this line. Whatever you are writing here in this brackets, just take the mod of that. Z3 minus Z2 divided by Z2 minus Z1. I'm sorry, Z1 minus Z2 it will be, because Z1 minus Z2. You are going from R to Q, then P to Q. So Z1 minus Z2. Okay, the mod of this into e to the power I theta. This is the rotation theorem, that if you want to have this coordinate, this complex number, and you know the theta with which we are going to rotate this PQ line, okay, then you can calculate always the Z3 thing by using this formula. This is called the rotation theorem. Z3 minus Z2 upon Z1 minus Z2 is equals to Z3 minus Z2 upon Z1 minus Z2 mod of that into e to the power I theta. Theta will be given to you, Z1, Z2 will be given to you. You have to calculate just the Z3 value. So this is the rotation theorem. This will be asked. This has been asked in many JEE exams. So keep it in mind. We'll move on to the cube root of unity. One question is always from this topic, cube root of unity. Always. If any question is from complex numbers, then cube root of unity is involved. So cube root of unity, that is cube root of unity, that is 1. Let's say this is x. Well, let's say it is z, because we are dealing with complex number here. So if this is true, then z cube is equals to 1 is true. This implies z cube minus 1 is equals to 0 is true. This implies we can factorize this, which will give us the z minus 1 in two factors, z minus 1 and z square plus z plus 1 is equals to 0. Fine. So this gives us that z is 1 or two more roots, which are called omega and omega square. Where omega is 1 is the root because of this, and because of these two we have omega and omega square. Where omega is minus 1 plus I root 3 by 2, which is a complex number. Okay, and omega square, if you do the square of this, you will get omega square as minus 1 minus I root 3 by 2, which is the, you can see that this is omega square is omega bar, conjugate of omega. Can you see that? Because the imaginary part is, the sign of imaginary part is changed. So now the properties related to the cube root of unity. Okay, related to cube root of unity. First property, omega square plus omega plus 1 is 0. This will be used, so keep it in mind. Then omega square plus omega to the power 2r plus omega to the power r plus 1 is also 0. So keep this in mind, you will have this thing already. And in this, r belongs to integers. Let me write integers with I, because I have used z in complex number. So integers, r belongs to integer number, but not a multiple of 3. It should not be a multiple of 3. In that case, it will be, this value will be 3. Okay. Now, third important thing is omega cube is always 1. Omega is something, omega square is something, but omega cube is 1. And that's why omega cube square is also 1, which implies omega to the power 6 is 1. So multiple of 3 will be, if r is a multiple of 3, that means r is 6, 9, 12, anything. It will be, the value will be omega to the power 3r will be always 1 for r belong to any integer. Fine. Now we are going to learn something about ellipse, straight line, and hyperbola and circle in case of with complex numbers. So first of all, the distance between two complex numbers. If you have two complex numbers p and q, let's say this is z1, this is z2, they will be given to you. So the distance will be, from this distance d will be mod of z2 minus z1, or you can say z1 minus z2, doesn't make a difference, as we have learned that mod of z is equals to mod of minus z. So this is the distance. You subtract the real part from real part, you subtract the two complex numbers and you take the mod of that. That will give you the distance between two complex numbers. It's just like coordinates. Okay, let's say z1 is x1 plus I y1, you will see it here. This is x2 plus I y2. Fine. This is just like x1 comma y1 and x2 comma y2. What do we do in straight lines? We take the root of x1 minus x2 whole square plus y1 minus y2 whole square. In this case, if a complex number d of mod of z2 minus z1, x2 minus x1 plus I y2 minus y1, mod of this will be root of x2 minus x1 whole square plus y2 minus y1 whole square. So these two are same. So that means it's just like the real system. The difference is that the representation of a complex number, and real system is different, and nothing else is different. Okay, so you can always formulate all this distance formula. Then we have a section formula, which is given by section formula. This is given by z is equals to mz2 plus nz1 upon m plus n. This is for plus minus. Okay, you can have plus minus. Plus is for internally. Okay, plus is for internal division, and minus is for external division. Fine. So this is just like the distance formula and section formulas for in the case of straight lines. Now we have something, amplitude of z. This is called theta. If this is given to you, that amplitude of z is pi by 2 or any angle given to you, this is a ray emanating from the origin. If this is amplitude of z minus z1, then it will be originating from z1. In this case, you can write it z minus 0, where 0 is the origin. So ray emanating from origin. Inclined, this will be inclined at an angle theta to x-axis. So if anything about amplitude of z is given, then you will have the theta, the angle with which it is inclined to the x-axis. It can be minus 3 pi by 2, it can be plus 5 pi by 2, anything. Fine. So this is about the amplitude of z. Now we have the perpendicular bisectors of a line joining A and B. That will be z minus A is equals to z minus B. A complex number, the locus of a complex perpendicular bisector of two complex numbers A and B. Okay, this is the perpendicular bisector that will have this property, that will satisfy this z will satisfy this property. Okay, so this is the locus of perpendicular bisector z. Now we have another formula. The equation of line joining z1 and z2 is given by, if we have two z1 and z2, the equation of line can be determined. So equation of line joining z1 and z2 is given by z, this is the line, just like y is equals to mx plus c, t z1 minus z2 plus z1. Fine. Where t is a real parameter, not a complex parameter. So this is the equation of line. First of all, subtract it, then z1 minus z2, then z1 plus the t times that thing, z1 minus z2, or z. Okay, so you can write it as the equation of line joining z1 and z2. Then this one is important. It has been used many times. So equation of circle having center z0 and radius rho is z minus z0 is equals to rho. Okay, they can tell you z minus 2 plus 3i mod of this is equals to 5. Then the radius will be 5, the center will be 2 comma 3. So you can make it here. 2 comma 3 is this, and with radius 5 you will have this circle. So to solve many questions, these geometry can be used. Okay, diagram making can be used. So for that you have to know that what is the center, what is the radius, where can it be made, where we can make it. Okay, so you have to just make the Cartesian plane and just see that where the point lies, where what is the radius, what we can do about it. Fine. So the next formula, this was about circle. And then the next formula is about ellipse and hyperbola. If ellipse is given, then it will be z minus z1 plus z minus z2, because ellipse has two foci. So this is one of the foci, this is two of the second foci, is equals to k. Okay, which is greater than mod of z1 minus z2 always. So this is the locus of ellipse. Z is the locus of ellipse whose foci are z1 and z2. Then for hyperbola, it will be z minus z1 plus z minus z2 is, okay, this is not plus, it is minus, and mod of this is equals to k, which is less than z1 minus z2. This inequality is just like the eccentricity. That eccentricity is greater than 1 in case of hyperbola and eccentricity is less than 1 in case of ellipse. Eccentricity is equal to 1 in case of parabola. So this is the case. Then, okay, so in here the z1 and z2 are also foci. This is the case of hyperbola. If you are given the difference, if you are given the addition, then it will be an ellipse. The focus will be an ellipse of z. The focus will be an ellipse. If you are given something like this, z minus z1, then z minus z2 is equals to k, which is not equals to 1 or 0. Okay, then the locus is a circle. Locus of z is a circle. So these are the relation between complex number and the straight line, ellipse, circle, all the conic sections. So many questions can be asked relating to this, because this can be a hybrid problem of important type, and this can be asked in 4 numbers, 5 numbers. So you have to revise these formulas. These are very important, and I have told you about everything which is related to the straight line, circle, conic section, any conic section, and this complex number. So here we complete our complex numbers.